friends, welcome you all to Think Max. We are in class 10 Max, chapter 12, surface areas and volumes. In this session, we are going to discuss about the exercise problems 12.2, question numbers 1 to 8. That is, all the questions from exercise 12.2. First question, a solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter and the height of the cone is equal to its radius. Find the volume of the solid in terms of pi. So here there is a shape. The shape is in the form of a cone. This cone is standing on a hemisphere. So in the hemisphere, a cone is standing on its top. So there is a cone on top. So this is the shape. So what are the data given with both their radius? So radius of the cone as well as radius of the hemisphere is equal to 1 centimeter. So radius is 1 centimeter. So this is the base part. In this base part, radius equal to 1 centimeter. R is equal to 1 centimeter. And height of the cone. So height of the cone is also equal to 1 centimeter. So height is also equal to 1 centimeter. So these are the data given. We have to find out the volume of the solid. So volume of the solid means what is inside the solid. So surface area means outer area. So outer area, volume means how much capacity will be held inside the cone. Held inside the cone. So in the same way, how much volume is held inside this hemisphere. So it is nothing but volume of this cone plus volume of the hemisphere will give the volume of the solid. Here they are asking the answer in terms of pi. So no need to substitute the value of pi. So just stop the answer with the pi. Now let us start the solution. So it is given that radius of the cone and radius of the hemisphere are same, which is 1 centimeter. Also height of the cone is also 1 centimeter. So these are the data given. We have to find out the volume of the solid, which is nothing but volume of hemisphere plus volume of cone. So what is the formula for volume of hemisphere? It is nothing but 2 by 3 pi r cube plus volume of cone formula is 1 by 3 pi r square h. So these are the formulas. So here what is common here? Pi is common and in denominator we have 3 on both. So pi by 3 and then r square. R square is common. Remaining we have 2r plus here we took pi r square by 3. So only h is there. So 2r plus h. So keep the value of pi as such. Pi by 3. What is r? R is 1 square. So 2 into r is 1 and h is also 1. So we will get pi by 3. 1 square is 1 into 2 into 1, 2. 2 plus 1 it is 3. So cancelling this 3, we will get pi. So it is pi centimeter cube is the volume of the solid. Okay, children, do you understand? So this problem is very simple. So moving on to the next problem. Second question. Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminum sheet. The diameter of the model is 3 centimeter and its length is 12 centimeter. If each cone has a height of 2 centimeter, find the volume of air contained in the model that Rachel made. Assume the outer and inner dimension of the model to be nearly the same. So outer and inner dimensions are same. So now what is given? An engineering student is making a model. So what is the shape of the model? It has a cylinder. So it has a cylinder with two cones attached at its end. So on both the ends, two cones are attached. On top and on bottom, cones are attached using aluminum sheet. Now what are the data given? The diameter of the model is 3 centimeter. That is this diameter. Diameter, that is base will have a circular shape. Its diameter. So diameter is 3 by 2. I'm sorry, diameter D is 3 by 2. So radius will be 3 by 2 centimeter. So this is the radius. So this part will be 3 by 2 centimeter. Now, and its length means length of this model. This length is total length of the model is 12 centimeter, and each cone has a height of 2 centimeters. So height of this cone is 2 centimeter, and height of the cone at the top is also 2 centimeter. So now what will be the height of this cylinder? So height of the cylinder will be from the total height. We have to take out the height of both the cones. Both the cones are of same height. So it is 2 plus 2. So it is 12 minus 2, 12 minus 4, which is 8 centimeter. So height of the cylinder equal to 8 centimeter. So these are the data given. We have to find out the volume of air contained in the model. So it is nothing but volume of air in the top cone, volume of air in the bottom cone plus volume of air in the cylinder. Both the cones are of the same dimension. So it is nothing but 2 into volume of cone plus volume of cylinder will give the volume of air in the model. So let us start the solution. So radius of the cone is equal to the radius of the cylinder. So it is given that the diameter of the model. So both the diameter of the cylinder as well as diameter of the cone are same. So diameter is given as 3 centimeter. So radius will be its half. So 3 by 2 centimeter. Height of the cone. Height of the cone h is given as 2 centimeter. So height of the cylinder. To find height of the cylinder, we have to do this calculation. That is, from the total height, we have to take out the heights of the cone. So height of the cylinder is denoted by h dash. So height of the cylinder h dash is nothing but 12 minus 2 plus 2. So it is 12 minus 4, which is equal to 8 centimeter. So this is the height of the cylinder. Now we have to find the volume of air contained in the model. So it is nothing but volume of the cylinder plus 2 into volume of cone. So what is the formula for volume of cylinder? It is nothing but pi r squared h. So cylinder height is denoted by h dash. So pi r squared h dash plus 2 into volume of cone. Volume of cone is nothing but 1 by 3 pi r squared h. So what is common here? Pi r squared is common. So take that outside, pi r square, and remaining we have h dash plus 2 by 3 h. So keep this pi as such. We will substitute the value of pi at the end. What is radius? So radius of the cone and radius of the cylinder are same, which is 3 by 2. So r square is 3 by 2 into 3 by 2 h dash. What is h dash? It is 8. So 8 plus 2 by 3. What is h? H is 2. Now pi into 3 3s are 9. In the denominator 2 2s are 4. So in the bracket we have 8 plus 2 into 2, it is 4 by 3. So we have 9 pi by 4 into, taking the LCM, we have 3 8s are 24 plus 4 divided by 3. So calculating here. So let me do the calculation on top. So it is 9 pi by 4 into 24 plus 4 is 28. So 28 by 3. So now cancelling 4 and 28. 1 4s are 4, 7 4s are 28. 1 3s are 3 and 3 3s are 9. So what we have? 3 pi into 7. So now substitute the value of pi. So pi value takes 22 by 7 into 7. So this 7 gets cancelled. So only it is 3 into 22. So it is 66. So 66 centimeter cube. So this is the volume of the solid contained in the model. Okay, children, I hope you can understand this example. It is very simple. Just we have to find out the radius of the cone and cylinder and height of the cone and cylinder. Substitute the values. So you can substitute the value of pi at the end. So that cancellation will be very easy. So the answer is 66 centimeter. So moving on to the next problem. A gulab jamun contains sugar syrup up to 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with two hemispherical ends with length 5 centimeter and diameter 2.8 centimeter. So there is a container here. In this container there are so many gulab jamuns. How many gulab jamuns? 45 gulab jamuns are there. It is in the shape of a cylinder. How the cylinder is formed? With two hemispherical ends. So this is the shape of the gulab jamun. That is, it is in the form of a cylindrical shape with two hemispherical ends. So this is the shape of the gulab jamun. Okay. How it is given? It is given as its length is 5 centimeter. So total length is 5 centimeter and diameter. So this is the diameter. So this diameter is 2.8 centimeter. So what will be the radius? Radius will be 2.8 by 2, which is 1.4. So this is the, if we take the center point, this value, this line will be the radius. So from this center point, if I draw a line in this way, this will also will have the value 1.4. So this value will be 1.4. So that is, height of this hemisphere is 1.4. Total length is 5. So this length of this length of the cylinder will be 5 minus 1.4 plus 1.4, which is equal to 5 minus 2.8, which is 2.2. So height of this cylinder is 2.2 centimeter. Okay, children, I hope you can understand this. Let us do this clearly. So this is the shape of the gulab jamun with cylinder at the center and two hemisphere at the ends. So it is given that total length is 5 centimeter and the diameter. So that is, diameter is 2.8 centimeter. So radius. So this will be the radius. This will be the radius. So radius will be 1.4 and this is also the radius of the hemisphere. So its radius is 1.4 for hemisphere as well as cylinder. So if we draw a line in this way from the center to the hemisphere, this is also the radius. So this value will be 1.4 and this is also 1.4. So now we have to get this height of the cylinder. So how this value will be? It is nothing but from the total length 5, we have to take out this lengths 1.4 and 1.4. So it will be 2.2 centimeter. Okay, children, I hope you can understand this. So let us start writing the solution. So radius of the hemisphere and radius of the cylinder. It is nothing but 2.8 by 2, which is 1.4 centimeter. Both their radius are same. Now height of the cylinder. From the total height 5, we have to take out the height of the hemisphere, which are both 1.4. So it is 5 minus 2.8, which is 2.2 centimeter. So this is the dimension of the gulab jamun. So how many gulab jamuns are there? 45 gulab jamun. So first we have to find the volume of one gulab jamun. So when we get the answer, if we multiply it by 5, we will get the volume of 45 gulab jamuns. Now what we have to find? approximately how much syrup is formed. So here it is given that a gulab jamun contains sugar syrup up to 30% of its volume. So from the volume, if you multiply it by 30%, we will get the syrup volume of the syrup. Okay, children? I hope you can understand the concept. So let us start calculating. Now, volume of one gulab jamun is nothing but volume of one cylinder plus volume of two hemisphere. Okay. So now volume of a cylinder. What is the formula for volume of a cylinder? Volume of the cylinder is pi r squared h. So volume of two hemispheres. So 2 into what is the volume of hemisphere? It is 2 by 3 pi r cube. So these are the formulas. So what is common here? You can take a pi and r square. So pi r square if we take outside it will be h plus 2 into 2 4 by 3. Here pi r square is taken, only 1 r will be remaining. So substituting the values, pi takes the value 22 by 7. What is r? R is 1.4. So 1.4 into 1.4. What is h? H is 2.2. So this is h is height of the cylinder. It is 2.2 plus 4 by 3 into r. R is 1.4. So here 1 sevens are 7, 2 sevens are 14. So here it is 1.4, so it is 0.2. So we will get 22 into 0.2 into 1.4. And here the LCM is 3. So taking the LCM as 3, we have to multiply 2.2 by 3. So we will get 6.6 plus 4 into 1.4 is 5.6. So 22 into 0.2 is 4.4 into 1.4. In the bracket we have denominator 3, 6.6 plus 5.6 is 12.2. So it is 4.4 into 1.4 into 12.2 divided by 3. It is 4 3s are 12. 0.2 is not divisible by 3. 0. So if you add 0, we will get 20. So it is 6 3s are 18. Again we will get 20. So it goes on like this. So 6 6 6. So approximating we will get 4.4 into 1.4 into 4.07. Now calculating these values. So let us calculate here. First 4.4 into 1.4. So 4 4s are 16, balance 1. 4 4s are 16 plus 1, it is 7. So 4.4 into 1. So 44. 6, 7 plus 4, 11, balance 1 and it is 6. So it is 616. The decimal is before two numbers. So 6.16. Now we have to multiply 6.16 with 4.07. So 6 sevens are 42, balance 4. 1 sevens are 7, 7 plus 4, 11. 6 sevens are 42 plus 1, 43. So multiplying with zeros, we will have zeros. So 6 fours are 24, balance 2. 1 fours are 4, 4 plus 2, 6. 6 fours are and 24. Now adding 2, 1 plus 0, 1, 3 plus 4, 7, 4 plus 6, it is 10, balance 1, 1 plus 4, 5, 2. So how many decimal? 1, 2, 3. So we will have 250.712. So this is the value. So how many decimals? 1, 2, 3. So it is, I think 1, 2, 3, 4. I'm sorry. How many decimals here? Here there are 2 decimals and we have 2 decimals. So the decimal will not come here. So it is decimal before 4. 1, 2, 3, 4. So it is 25.07. So approximately this is 25.07. So after 7 the number is less than 5. So no need to add here. So it is 25.07 centimeter cube. So this is the volume of 1 gulab jamun. So let us find the volume of 45 gulab jamuns in the next page. Volume of 45 gulab jamuns is nothing but 45 into volume of 1 gulab jamun. So which is nothing but 45 into, what is the volume of 1 gulab jamun? It is 25.07. So if we multiply 45 and 25.07, we will get 1128.15 centimeter cube. So they are asking for the volume of the syrup. It is nothing but 30% of the volume of gulab jamun. So 30% is 30 by 100 into gulab jamun volume is 1128.15. So a 0 gets cancelled. So 3 divided by 10 is 0 0.3. So 0 0.3 into 1128.15. So if we multiply the values, 3 5s are 15, balance 1, 2 ones are 3, plus 1 is 4, 3 8s are 24, balance 2, 3 2s are 6, 6 plus 2, 8, and 3 ones are 3, 3 ones are 3. So the decimal is before 3 numbers. So putting a decimal here, it is 338.445. So approximately 338.45. So you can add the values, there is 5. So 338.45 centimeter cube. So this is the volume of the syrup. Okay, children, I hope you can understand this problem. So moving on to the fourth problem. A pen stand made of wood is in the shape of a cuboid with four conical depressions to hold pens. The dimensions of the cuboid are 15 centimeter by 10 centimeter by 3.5 centimeter. The radius of each of the depression is 0.5 centimeter and the depth is 1.4 centimeter. Find the volume of wood in the entire stand. So this is the pen stand given. It is made of wood with four conical depressions. So it has a conical depression to hold this pen. Now what they are asking for the volume of wood. So in this volume of wood, as they have made a conical depression, this space, this conical space will be hollow. So from the total volume, which is in the shape of a cuboid. So from the volume of the cuboid, we have to subtract the volume of cone. How many cones are there? 4 cones are there. So volume of cuboid minus 4 into volume of cone will give the volume of the wood in the entire stem. So what are the data given here? So it is the data of the cuboid here. So cuboid, its length, breadth and height are given. So what is the length? Length is 5 centimeter. So L is equal to, not 5, 15 centimeter. Breadth. Breadth is 10 centimeter and height. Height is equal to 3.5 centimeter. So this is the dimensions of this cuboid. And the next part, the radius of each of the depression. How is the depression? Depression is in the form of a cone. So that is a conical depression. So for the one depression, we have this dimension. So this dimension is same for all the depression. So radius is given as 0.5. So R is equal to 0.5 and the depth. So this is the depth. So this is the depth. So this depth means height. Height is equal to 1.4 centimeter. So these are the data given. So now let us start the solution. So length of the cuboid, L is equal to 15. Breadth is equal to 10 centimeter. Height is equal to 3.5 centimeter. So radius of the cone is given as 0.5 centimeter. Height of the cone. So there are two heights, height of the cuboid and height of the cone. So let us denote the height of the cone as h dash. H dash equal to 1.4 centimeter. So these are the data given. Now we have to find out the volume of wood. So in this volume of wood, this cone is hollow. So from the total volume, which is the volume of the cuboid, we have to remove the 4 times the volume of the cone to get the required volume. So volume of cuboid minus 4 into volume of cone will give the answer. So what is volume of cuboid? It is nothing but L into B into H minus 4 into volume of cone. So what is the volume of cone formula? It is nothing but 1 by 3 pi r squared h. So L here cone is denoted by h dash. LBH, L value 15, B value 10 and H value 3.5 minus 4 divided by 3 into pi 22 by 7. What is R? Radius of the cone. What is the radius of the cone? It is 0.5. So 0.5 into 0.1 into height. Height of the cone is 1.4. Now 10 into 3.5, this decimal will vanish. So it is 15 into 35 minus what we can cancel here? We can cancel this 1.4 and 7. So 1 sevens are 7, 0.2. So we have 4 into 22 into 0.5 into 0.5 into 0.2 divided by 3. So what is that is 15 into 35. Do the calculation here. 15 into 35. So 5 5s are 25. 2. So it is 75. I'm sorry. 5 3s are 15. Balance 1. So it is 45. So 5, 12. Balance 1, 5. So 15 into 35 is 525. Minus, we have to do the calculation here. 4 into 22 is 88. So 88 into 0.5. So 8 5s are 40. Balance 4. 8 5s are 40. Plus 4, it is 44. The decimal is before one number. So we will get 44. So 44 into 0.5. So this decimal will not be needed. After decimal, if there is 0, it is not valuable. So 44 into 5. 4 5s are 20. Balance 2. 4 5s are 20. Plus 2, it is 22. So the decimal is before one number. So it is 22. 22 into 0.2. So 2 2s are 4, 2 2s are 4. So decimal is before one number. So it is 4.4 divided by 3. So 525 minus 4.4 divided by 3 is 1 point. So there will be 14 here. So it is 4 3s are 12. Balance will be 2. So it is 6 3s are 18. Again balance 2. So it goes on like this. So we can keep this as 7. So 1.467. So if we subtract, we will get almost 523.5 centimeter cube. This is the answer for this problem. Okay children, we understand this? With this, problem 4 is completed. Let's move on to the next problem. Question number 5. A vessel is in the form of an inverted cone. Its height is 8 centimeter and the radius of its top is 5 centimeter. It is filled with water up to the brim. When lead shots, each of whom is a sphere of radius zero point 0.5 centimeter are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. So there is a vessel in the shape of an inverted cone. So it is filled with water up to the brim. So up to the brim, the water is filled up. So height of this cone is height of the cone is 8 centimeter. So this is the height of the cone and the radius. So radius is 5 centimeter. So it is open and the radius is 5 centimeter. When the lead shots, so this is the lead shot. It is in the shape of a spear. So and it has a radius 0.5 centimeter. When this lead shots are dropped into the vessel. So they are dropping some lead shots into the vessel. When they are dropping into the vessel, what happens? 1/4 of the water flows out. So from this cone, 1/4 of the water flows out. So what happens? The volume of the water will be reduced. So this portion will be falling down. So in this portion, there will be some water. This water will flow down when the lead shots are poured into the cone. So now the water level will be up to this. What we have to find out? Find the number of lead shots dropped in the vessel. So when 1/4 of the water flows out, we have to find out how many lead shots should be dropped inside the cone so that 1/4 of the water is flowing out. So now let us start the solution. First let us write what are the data given. So here radius of the cone is 5 centimeter. Height of the cone is 8 centimeter. There are two radius, cone and the sphere. So let us denote the radius of the sphere R dash as 0.5 centimeter. Now first we are going to find how much amount of water is in the cone. Before dropping this lead shot, we have to find how much amount of water is in the cone. So the water is up to the brim, that is up to the top. So we have to find the volume of water in the cone. That is nothing but volume of cone. What is volume of cone? It is nothing but 1 by 3 pi r square h. 1 by 3 pi r square h. So let us keep the value as pi and we will use the value of pi at the end. So it is 1 by 3 pi. What is r? R is 5. So 5 square, h is 8. So pi by 3 into 5 square is 25 into 8. What is 25 into 8? 5 8s are 40, balance 4. 2 8s are 16. 16 plus 4, it is 20. So it is 200 pi by 3. So this is the total volume of water. So total volume of water in the cone at the beginning is 200 pi by 3 centimeter cube. Now we have to find out the how much water flowing out. How much water is flowed out is given that 1/4 of the water has flows out. So volume of water flows out equal to 1/4 of volume of water in the cone. So 1 by 4 into how much volume of water is there? 200 pi by 3. So it is 1 4s are 4, 5 4s are 20 and this 0. So it is 50 pi by 3. This much water has come out. So this is the amount of water. This is 1/4 of water. So 1/4 of water, this has come out. So it is 50 pi by 3. Now we have to find out the number of lead shots needed for this water to come out. That is 1/4 of the water to come out. First let us find out the volume of this sphere. When we put this lead shot here, so this volume of the sphere will be equal to the volume of the water coming out. So volume of one lead shot. Lead shot is in the shape of the sphere. Volume of one sphere. So what is the formula for volume of sphere? It is 4 by 3 pi r cube. So sphere is has radius r dash. So 4 by 3 pi r dash is 0.5 whole cube. So 0.5 whole cube is nothing but 0.125. So 4 by 3 pi 0.125. So multiplying with 4, 4 5s are 20, balance 2, 4 2s are 8, 8 plus 2, 10, balance 1, 4 1s are 4, plus 1 it is 5. So it is 0.5 pi by 3. So after decimal, if there is 0, it is not valid. So it is 0.5 pi by 3. This is the volume of one lead shot. In the next step, we have to find out number of lead shots needed so that 50 pi by 3 volume of water has been flown. This will be done in the next page. Previous page, we found the volume of water in the cone and the volume of water flowing out and the volume of the lead shot. So now the last part is we have to find out the number of lead shots needed so that this much amount of water, 50 pi by 3 water is flowing out. So this is nothing but if we put some lead shot, how much water will be flowing out? It will be equal to the volume of that lead shot. So what will make the formula? Number of lead shots. Number of lead shots into volume of lead shot will be equal to the volume of water flowing out. So if you put some lead shots and multiply it that by volume of one lead shot, then it will be equal to the volume of water flowing out. So number of lead shots will be equal to volume of water flows out. This is in multiplication. Volume of one lead shot is in multiplication. So it will come to division. So volume of one lead shot. I'm sorry. So volume of water flowing out is 50 pi by 3 divided by volume of one lead shot is 0.5 pi by 3. So in the numerator we have 50 pi by 3. In the denominator we have 0.5 pi by 3. So if you put it in the product, denominator will come to numerator, numerator will come to denominator. So this pi gets cancelled and this 3 gets cancelled. So it is 50 divided by 0.5. So let us do the calculation here. So 50 divided by 0.5. To avoid decimal in the denominator, multiply by 10 on numerator and denominator. So it will become 50 divided by 5, not 50. So 500. So 50 into 10 is 500 divided by 5. So which is equal to 100. So number of lead shots needed so that 1/4 of the water flows out will be equal to 100 lead shots. So number of lead shots equal to 100. So this is the answer we need. Okay children, I hope you can understand this problem. So moving on to the sixth problem. A solid iron pole consists of a cylinder of height 220 centimeter and base diameter 24 centimeter, which is surmounted by another cylinder of height 60 centimeter and radius 8 centimeter. Find the mass of the pole given that 1 centimeter cube of iron has approximately 8 gram mass. So here what is given? There is an iron pole. How this iron pole is formed by a cylinder. So there is a big cylinder and a small cylinder. So this is the iron pole. So the values of the cylinder are given, dimensions of the cylinder are given. We have to find out the mass of the pole. So what weight it occupies. Now we have to find out the volume of this cylinder, big cylinder and small cylinder. So if you add, we will get the total volume of this iron pole. Now what we have to do, it is given that 1 centimeter cube of iron has approximately 8 gram mass. So we will know the volume, complete volume. So how much it occupies, we will know the volume of this solid iron pole. So with that we have to multiply the 8 gram mass to find out the mass of the total volume of iron. Okay children, I hope you can understand. So let us start the solution. Now I took the big cylinder and the small cylinder. So radius of big cylinder. So what is given? So this is the value here, it is high. So this is the value of the big cylinder. So a solid iron pole consists of a cylinder of height 220 centimeters. So height of big cylinder H is equal to 220 centimeter and base diameter. So this base diameter is 24. So radius will be 24 by 2 equal to 12 centimeter. Now we have to find out the volume of the big cylinder. So cylinder formula is pi r square h. So pi, what is r? It is 12. So 12 into 12, h is 220. So pi value you can take, it is not given. Yes, it is given. Use pi is equal to 3.14. So 3.14 into 12 into 12 into 220. So if you multiply all these values, you will get 99475.2 centimeter cube. So this is the answer for volume of the big cylinder. Now we have to find out the volume of small cylinder. So what are the dimensions given? They are the dimensions of small cylinder. So height of the small cylinder is h dash is 60 centimeter, and radius of the small cylinder is, radius is directly given. So radius is given as 8. So it is 8 centimeter. Now volume of small cylinder equal to pi. We took it as r dash. So r dash square h dash. So pi value is 3.14. R dash is 8 square. So 8 into 8. H dash is 60. So if you multiply all the values, you get the answer as 12057.6 centimeter cube. So the multiplication is very simple. I hope you can do this direct. So now we have to find out the total volume. So total volume is nothing but volume of big cylinder plus volume of small cylinder. So what is this volume? 99475.2 plus 12057.6. So if we add these values, we will get total volume of this iron port. So it is 111,532.8. So this is the total volume of this iron pole. Now what is given? Mass of 1 centimeter cube of iron is 8 gram. So mass of this centimeter cube, that is 111,532.8 centimeter cube of iron will be, it is nothing but you have to multiply by 8. So 8 into 111,532.8. So if you multiply, 8 8s are 64, balance 6, 2 8s are 16, 16 plus 6 is 22, balance 2, 3 8s are 24, plus 2 it is 26, 8 5s are 40, plus 2 it is 42, and 4 here, 8 1s are 8, 8 plus 4, 12, balance 1, 8 ones are 8, 8 plus 1 9, and 8. So we will get 8922624, and the decimal is before 1 point. So this is the value. So this is in grams. So the grams is higher. So we can convert it to kilogram. So converting it to kilogram, we have to divide by 1000. So 89226.4 divided by 1000. So we have to move another 3 places. There are 3 zeros. We have to move. Already decimal places here. So we have to move here another 3 places. So the decimal will come here. So the answer is 892.2624 kilogram. So it is approximately 892.26 kilogram. Okay, children, you can approximate or write the value as such. So I hope you can understand the 6th problem. So moving on to the next 7th problem. A solid consisting of a right circular cone of height 120 centimeter and radius 60 centimeter standing on a hemisphere of radius 60 centimeter is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder. If the radius of the cylinder is 60 centimeter and its height is 180 centimeter. So what is this question? In a cylinder, a cone and a hemisphere is placed. How it is placed? A right circular cone of height standing on a hemisphere. That means hemisphere will be at the base. So on this hemisphere, this cone will stand. Okay. So this picture, that is this toy. This toy is placed inside the cylinder. Already we have seen this picture in the previous problem. The same as such, and a toy is placed. It is in the shape of a hemisphere and a cone is placed on this top. So this is a toy. This toy is placed inside the cylinder. So the cylinder has full of water. So when we place this toy, what will happen? Some water will come out. What is the amount of water coming out? It is nothing but volume of this cone plus volume of this hemisphere. So how much water will be remaining in the cylinder? So it will be nothing but from the total volume of the cylinder, we have to take out the volume of cone and volume of hemisphere. So this will give the volume of water left in the cylinder. Okay, children? So let us write the problem. So it is given that radius of the cylinder. So what is the radius of the cylinder? If the radius of the cylinder and height is 180 centimeter. So capital R is equal to 60 centimeter and height is equal to 180 centimeter. So volume of water in the cylinder will be pi R square H. So pi, I'm going to keep the value as pi, and at last we will substitute the value of pi. What is R? It is 60 into 60 into 180. So we can just write it as pi into 3600. So here it is 60 into 60 is 3600 into 180. So this is the volume of water in the cylinder. Now volume of water flowing out. So how much water will flow out? It will be equal to the volume of this cone and volume of this hemisphere. Okay. Volume of cone is nothing but 1 by 3 pi r square h. So 1 by 3 pi r square h. Volume of the hemisphere is nothing but 2 by 3 pi r cube. So we have to substitute these values. What are the values for this? So here let me write radius of cone. This is the radius of the cone. It is given that a right circular cone consisting of height is 120 centimeter and radius is 60 centimeter. So radius is 60 centimeter, which will be equal to the radius of hemisphere. Both the radius of hemisphere and radius of cone are same. What is the height of the cone? Height of the cone is 120 centimeter. So height of the cone h is equal to 120 centimeter. Now substituting these values, it is 1 by 3 pi. What is r? This is the value of r. R is 60. So 60 into 60. H value is 120 plus 2 by 3 pi into r cube. R cube means 60 into 60. So if we simplify this, 1 by 3 pi, it is 3600 into 120 plus 2 by 3 pi. Here it is all, this value is 3600 into 60. Now what is the volume of water left out? So this is the value for volume of the cone as well as volume of the hemisphere. Now what will be the volume of water left in the cylinder? So it is nothing but total volume. What is the total volume? It is nothing but pi into 3600 into 180 minus, we have to take out the volume of water flowing out. What is that? 1 by 3 pi into 3600 into 120 plus 2 by 3 pi into 3600 into 60. Now what is common here? Pi into 3600 is common. So pi into 3600 can be taken out. Remaining we have 180 minus, here pi into 3600 is taken. Remaining 120 by 3 minus, because minus into plus is minus. Here 2 by 3 into 60. 2 by 3 into 60. So 2 by 3 into 60. So let me do the calculation here. So pi is 22 by 7 into 3600 into, Here 180 minus 120 by 3 is 40 minus here 1 3s are 3, 2 3s are 6, 0. So it is also 40. So we will get 22 by 7 into 3600 into 180 minus 40 is 140. 140 minus 40 is 100. So this is the value. So if you multiply all these values, you will get 1131428.57 centimeter cube. Okay, children. So if you multiply 22 into 3600 into 100 and divide the value by 7, you will get 1131428.57. So this value is big. So we can convert this to smaller by converting this in meter. So let me convert here. So it is 1131428.57 centimeter cube. So if you convert this to meter, you have to divide by 100. So it is centimeter cube. So you have to divide by 100 three times. So 1131428.57. If you divide by 100 three times, so that in 100 we have two zeros. So we have to put three pairs of two zeros. So now how many zeros are there? 6. So 1, 2, 3, 4, 5, 6. So the decimal will come here 1.131. So approximately 1.131 meter cube. So this is the answer for this problem. Okay children, this is just the calculation here. I hope you can do the multiplication part easily. So this is the answer for this problem. 1.131 meter cube is the volume of water left in the cylinder. Now with this problem 7 is completed. So we will move on to the last problem of this exercise. Eighth one. A spherical glass vessel has a cylindrical neck 8 centimeter long, 2 centimeter in diameter. The diameter of the spherical part is 8.5 centimeter. By measuring the amount of water it holds, a child finds its volume to be 345 centimeter cube. Check whether she is correct. Taking the above as the inside measurements and pi is equal to 3.14. Now what is given? So there is a spherical glass vessel. So in this spherical glass vessel has a sphere at the bottom and this neck is in the shape of a cylinder. So these are the two shapes it takes. A child measured that its volume is 345. Now we have to check whether it is correct or not. So let us start the solution. It is given that volume of water in the measured by the child is 345 centimeter cube. Now what is the radius of the cylinder? So cylinder is 8 centimeter long and 2 centimeter in diameter. So for this cylinder, the diameter is 2 centimeter. So radius will be 2 by 2, which is 1 centimeter. Height means its length. Its length is given as 8 centimeter. So height of the cylinder, h is equal to 8 centimeter. So volume of the cylinder is nothing but pi r square h. So pi into 1 square into 8. So it means 8 pi centimeter cube. Now there is another shape which is the shape of a sphere at the bottom. So the diameter of the spherical part is 8.5. So radius of the sphere will be 8.5 by 2 centimeter cube. You can keep this 8.5 by 2 and calculate or simplify this. We will get 4.25 centimeter cube. So what is the volume of the sphere? What is its formula? Do you all remember? It is nothing but 4 by 3 pi r dash cube. So 4 by 3 into pi. What is r dash? It is either 8.5 by 2 or 4.25. So if we take 4.25, it is r cube. 4.25 into 4.25. Now we have to find out the total volume of the vessel. So it is nothing but volume of cylinder plus volume of sphere. So volume of sphere is 4 pi by 3 into 4.25 into 4.25 into 4.25, and volume of cylinder is 8 pi. So if you substitute the value of pi as 3.14, so 8 into 3.14 plus 4 into 3.14 divided by 3 into 4.25 into 4.25 into 4.25. Now, if we calculate this volume, so 8 into 3.14 is 25.12. So, if you multiply, you will get the answer as 25.12, and its answer, when you multiply and divide by 3, its answer is 321.39. So, if you add both these values, you will get 346.51 centimeter cube, but the child calculated as 345 centimeter cube. So this is not correct. So it is 346.51 centimeter cube. So you can write the answer as child is not correct. Okay, children, I hope you can understand this problem. With this, exercise 12.2 is completed. And also, the chapter 12 surface area and volumes is complete. Okay. In the next session, we will discuss about the chapter 13. Okay, children. Thank you. Thank you for watching.